Hey everyone, this is me, Ivy Shamju of S2CE from GCB, here to take the presentation on the topic Optical Fiber as a part of the Talkcog Online Tech Talk by CSI GECB. Let's see what's optical fiber. The content of the presentation is Introduction, what is optical fiber, structure, working principle, classification, optical fiber communication system, its importance in emerging technology, advantages and disadvantages, applications, and finally the conclusion. What is optical fiber? Fiber optic or optical fiber refers to the medium and the technology associated with the transmission of information as light impulses along a glass or plastic wire or fiber. Fiber optic wire carries much more information than conventional copper wire. Most telephone company long distance lines are now fiber optic. Optical fibers use light to send information through the optical medium. The structure of optical fiber. The structure includes a glass core, glass cladding, and plastic covering. The glass core is a central tube of very thin size made up of optically transparent dielectric medium and carries the light from transmitter to receiver. The core diameter can vary from about 5 micrometer to 100 micrometer. Glass cladding. The outer optical material surrounding the core having a reflecting index lower than core. It helps to keep the light within the core throughout the phenomena of total internal reflection. Plastic covering. Plastic coating that protects the fiber made of silicon rubber. The typical diameter of fiber after coating is 250 to 300 micrometer. The working principle of optical fiber. It's total internal reflection. When a ray of light travels from a denser medium to a grainer medium, such that the angle of incidence is greater than the critical angle, the ray reflects back into the same medium. This phenomena is called total internal reflection. In the optical fiber, the rays undergo repeated total number of reflections until it emerges out of the other end of the fiber, even if the fiber is bent. Here we can see the total internal reflection in optical fiber. The classification of optical fiber. On the basis of number of modes of propagation, the optical fiber are classified into two types: single mode fiber and multi-mode fiber. When talking about single mode fiber, it carries light pulses along single path. It uses laser light source and has a very small core and carry only one beam of light. And when about multi-mode fiber, many pulses of light generated by LED travel at different angles, can support less bandwidth than single mode fiber, and its data rates up to 1 gigabytes per second. Fiber optic cable. It contains one or several glass fibers at its core. Surrounding the fibers is a layer called cladding. FO cable may have 1 to over 1000 fibers. Some of the types of fiber optic cables are mentioned below with their pictures. First one is coir connector, the SC1. Next, the ST, that is the straight tip. The MTRG, mechanical transfer registered jack or media termination recommended jack. Next, the LZ, loosened connector or little connector or local connector. The other principle is refraction. Refraction is the changing direction of light when it goes into a material of different density. How optical fibers are made? 3 steps are involved in the manufacturing of the optical fiber, which are given below: making a preform glass cylinder, drawing the fibers from the preform, and last, testing the fiber. Next, the importance of optical fiber in emerging technology. The modern fiber optic internet is rapidly reaching new speeds in new markets. Today, fiber optics optimize the flow of communication across a number of industries and sectors, which include agriculture, healthcare, military, education, transportation, etc. Many enterprises stand to benefit from fiber optics, and the technology promises to remain at the forefront of digital communications. Next is the optical fiber communication system. Information source. It provides an electrical signal to a transmitter comprising an electrical stage. Electrical transmitter. It drives an optical source to give a modulation of the light wave carrier. Optical source. It provides the electrical optical conversion. It may be a semiconductor laser or an LED. Optical cable. It serves as transmission medium. Optical detector. It is responsible for optical to electrical conversion of data and hence responsible for demodulation of the optical carrier. It may be a photodiode, phototransistor and photoconductor. Electrical receiver. It is used for electrical interfacing at the receiver end of the optical link and to perform the signal processing electrically. And last, the destination. It is the final point at which we receive the information in the form of electrical signal. The advantages of optical fiber communication are: the life of fiber is longer than copper wire. Handling and installation cost of optical fiber is very nominal. It is unaffected with electromagnetic interference. Attenuation in optical fiber is lower than coaxial cable or twisted pair. The disadvantages are: highly skilled staff would be required for maintenance. Only point-to-point working is possible on optical fiber. Precise and costly instruments would be required. The applications. It is wider range of application. In telecommunication field, space applications, broadband applications, computer applications, mining applications, in medical applications, military applications, etc. And it goes on. When reaching to the conclusion of the presentation, this conclusion of our study on optical fiber communication have looked at how they work and how they are made, properties of fibers, applications, etc. Although this presentation does not cover all the aspects of optical fiber, it will have equipped you knowledge and skills essential to the fiber optic industry. Thank you.